Okay, so I want to know the average height of U.S. male. Let's Google that. Average. Pick that one up real quick. Now I can trust this Google estimate, 69.7 inches, which would be 5'9" and 0.7 of an inch. But let's get a little bit more of the information. When they did that, did they measure every male in the U.S.? Because I don't remember them measuring me. So how are they coming up with these things? So here we have a Wikipedia article on human height. I'm going to scroll down. Okay, here we go. We're going by country. I notice that average male height is the second column here. So I'm going to scroll down to the United States. You could do some interesting analyses on these, by the way. And we get the U.S. 5'9.5" for males over 20 plus years, so 20 years or older. But I wonder how they got that. Again, because I don't remember them measuring me. So I'm going to click on this citation, 154, and that's going to take me to a PDF. So what we have here, CDC, looks like we have a survey, and indeed we do. Data from the National Health and Nutrition Examination Survey. So, survey, we have a sample going on here. Let's get a little more of the details about this sample. So, here we have all the different things that were measured in this survey. On the first page, they typically tell more about the sample. So, it tells that they're sampling between 2007 and 2010. And it says we had 20,000 survey participants. Now, I'm guessing, looks like we covered the entire U.S. So males would probably be half of that, and then they may have measured younger males also under 20 years. So I could probably check throughout here, but you know, a few thousand males are what this sample consists of. So the next thing I'm wondering about, is it a random sample? Now I know that it's going to be a very difficult thing to take a random sample of the United States, males in the United States, because you would need a population list, which I'm not even sure if one exists, even with the census. So let's take a look at what they did here. They take a complex, stratified, and multi-stage probability sample. I won't get into the details of that too much, but it's essentially the next best thing to a random sample when you're dealing with a huge population like the United States. And it does involve some random sampling at the last stage. It talks about multi-stage here. So that's a pretty reliable thing to do. But even if it's reliable, even if it were completely random, remember that we have this issue of standard error. So now I want to actually go and look at those results specifically. So we have height in inches for males aged 20 and over on page 16. Nice clickable link. Takes me to this table. So 20 years and over, all racial and ethnic groups, which is what I was looking at. So 5,647. We have the total number that were in our sample that we're determining the average U.S. male adult height. And we have the mean of 69.3. So that would be 5'9" and 0.3 inches, a little less than 5'9.5" inches, which is interestingly a bit lower than Google predicted. It said 5'9" and 0.7 inches. So it'd be curious to go back to Google and see where they were getting their sampling from and see how their sample compares to this, because this looks like a pretty decent sample. But then again, Google does some pretty crazy things with informatics. So let's take a look at the standard error of the mean, 0.08. Now we're going to get more into that later, and let me see if I can expand this a little bit for you. Okay. So again, 5,600 adults, male adults 20 years or older in the US, mean was 69.3. How can I interpret the standard error of the mean? So we know that this is about how much we're off with our average. That doesn't mean that we just add 8 to this or subtract 8 to this, because we don't know in which direction we're off, and we don't know if we are off. In fact, 69.3 is our best guess. So what we tend to do is create a confidence interval. And the best way to do that is roughly 2 standard errors of the mean, so 0.16 below and 0.16 above. So that would give me 69.15 to 69.45. So both of these are 5'9" and a little under extra ½ inch there. And I'm 95% confident. So when I create this 95% confident interval, I just take 2 standard errors of the mean above, 2 standard errors below, and it creates this range in which I'm 95% confident that the true population mean, the true average height of US adult males, is within. So just to restate that, it's probably not exactly 69.3. But if I go 2 of these standard errors below, so down to 69.14, and 2 of these standard errors above the mean, so 69.46, somewhere between 69.14 and 69.46, that's my confidence interval. That's my 95% confidence interval. I'm 95% confident that the adult average male, US male mean, is somewhere within that range. Now, if I wanted to be even more confident that I was capturing the population mean in my confidence interval, I'd have to extend that confidence interval. I'd have to make it wider. The wider that I make my confidence interval, the more likely I am to catch the true mean, and the more confident I am that I am catching my true mean. On the other hand, if I want precision, if I want to just be within 0.05 or 0.03, I can also do that, but I'm much less confident now that my population mean is within that range. So if I wanted to say between 69.2 and 69.4, yeah, it's possible I'm still going to catch the population mean, but I'm less confident now. So my confidence interval is smaller, and my confidence level is also lower in that case. So just a closer look on what's going on when you see these published results. Oftentimes it's from a sample, not a population, and it's worth going in and checking if it's something important to you. It's worth going in and checking what the sampling method was. Was it just 30 of the person's friends, or was it 5,600 people almost randomly chosen from the population?